Ladies and gentlemen, if you haven't yet subscribed to my channel, please do so for more fire content and advise your friends and family to subscribe as well, or anyone that you think might benefit from this channel. Okay, thank you very much. So in this video, we're going to be looking at sigma notation. This is the introduction of sigma notation. This is only for grade 12 learners, ladies and gentlemen. Right. So what does sigma mean? Sigma means sum of terms. Sigma just means you are adding things, basically. It's a series. Sigma is a series, is a sum of things. Okay. So basically, let me analyze what does the first question mean before we can solve it, right? So sigma means the sum of, this means the sum of terms of this pattern. Beginning from when n is 1, this is where the n is beginning, and then ending at n equals to 6. So in simple terms, this is what we need. We need the sum of term when n is 1, n is 2, n is 3, n is 4, n is 5, n is 6. Do you see it? Because this is where you are starting. You are starting at n equals to 1. You are ending at n equals to 6. All right. And then you are going to get the actual values. So we need T1, we need T2, we need T3, we need T4, we need T5, we need T6. Okay. So let's get the values of these terms. So remember, this is our Tn formula, and then you have an n here. So we're going to substitute 2 to the power 1 for the first one. The second one, we're going to substitute 2 to the power 2, and 2 to the power 3, and so on, and so on, and so on, right? And then we're going to get values of these terms. 2 to the power 1, I'm sure we can all see that is still 2. 2 to the power 2 is 4. 2 to the power 3 is 8. 2 to the power 4 is 16. To the power 5 is 32. To the power 6 is 64. And then we're going to add all of them together. 2 plus 4 plus 8 plus 16 plus 32 plus 64. See it? And then we can easily just punch that on our calculators quickly to get our solution, which is 126. 126. You can also write it there to say this is equals to 126. So the sum of the first 6 terms of this pattern, this is a pattern, is 126 basically. And that is what sigma notation is. It just means the series or the sum. Sharp. On this one, we're starting at n equals to 3, and we're ending at n equals to 7. So in simple terms, we're looking for n equals to 3, n equals to 4, n equals to 5, n equals to 6, and n equals to 7. Right. So this is what we're going to do now. We're going to say, okay, I'm looking for t at 3. I'm looking at t at 4. I'm looking for t at 5. I'm looking for t at 6. And I'm also looking for t at 7. I'm sure it makes sense, ladies and gents. So t at 3, I'm going to substitute 3 then. So I have 2a. You remember you substitute on n because they put n there. If this was a, you'd substitute on a. You see, here they put n, I substituted on n. So I'm going to substitute 3. Then I have 2a, I substitute 4. I have 2a, I substitute 5. I have 2a, I substitute 6. I have 2a, I substitute 7. And then, what does this give me? Let's see. This give me 6a. This give me 8a. So I can see it's going to be 10a, 12a, and 14a. And then I need to add all this together. So 6a plus 8a plus 10a plus, so let me just put there for the 6a plus 8a plus 10a plus 12a plus 14a. Let's quickly get that on a calculator. So it's going to be 6 plus 8 plus 10 plus 12 plus 14. That gives me 58. Okay, perfect. Before we move on, there's another technique that I need you to have. You must know how many terms you are adding. How many terms did we add here? We added 1, 2, 3, 4, 5. There's a formula to get how many terms we're going to be adding. Is this. So the number of terms in sigma notation, it's always top. So the top number minus the bottom number plus 1. See? Let's use this formula here to get the number of terms added. So I'll say number of terms in this series. How many were they? There were 1, 2, 3, 4, 5, 6. You can get them by just saying the top number is 6, the bottom number is 1. So top minus bottom plus 1. So your answer is 6 because this one will cancel that. It means you're adding 6 terms here. On this one, the top number is 7, the bottom number is 3 plus 1. This is 4 plus 1, which is 5. It means you're going to be adding 1, 2, 3, 4, 5. This technique, you need to know it. You need to highlight it and write it somewhere in your book. It's going to be helpful in future as the level of sigma notation advances, where we're going to be using the sum formulas. This will prove helpful. Okay, thank you very much. We can move on, ladies and gents. So here they say, write the following in sigma notation. Okay, sharp. So I know that, okay, how many terms do I have? I have 1, 2, 3, 4, 5. Okay. Then I know that, okay, on my sigma, I'm going to have this. This is always n equals to 1 if they say you're converting from a pattern to sigma, because you're starting at term 1 then. Then this is the last term. So you have 5 terms in total. Perfect. Now you need to find the formula of the nth term of this pattern, right? That pattern can be quadratic, it can be geometric, it can be linear. You need to check. So let's check what this pattern is. Let me just write the values here. We have 31, 24, 17, 10, 3. And then we do this, right? What is the difference between, you say 24 minus 31, you get 7, right? 17 minus that, you get 7. 10 minus that, you get 7. This minus that, you get 7. But it means you are minusing, because this minus that gives you -7. This minus that, -7, and so on, right? And we can see that, therefore, this is a linear pattern. Sometimes you need to know that it's called arithmetic. Arithmetic pattern, which is going to basically be, therefore, Tn equals to, remember it's a plus d n minus 1, which is going to be Tn. Remember we said a is the first term, so the first term is 31. The d is the difference, which is -7, then n minus 1. Then we need to simplify, which is 31 minus 7n plus 7. So you have -7n plus 38, because 31 plus 7 gives you 38. So you write -7n plus 38, right? And then you can write this basically, because there are small terms, you can just add them and show how much the sum will be out of. So that plus 17 plus 10 plus 3. But ladies and gents, in the exam, if you leave it like this, it's still okay. You're going to get all the marks. But I advise you that if the amount of terms are little, just add them and show how much the sum is. So the sum is 85. And you have converted that to a sigma notation. We can move on to the next question. Okay. So here, ladies and gentlemen, we're going to do number 1 quickly. They say determine the value of. Okay. So they say we need to find the value of this. So here we have this. You have k equals to 1, then 4. You agree that in simple terms, it means you need k1, k2, k3, and k4. Because as we said, this is where you're starting. You're starting at k equals to 1, you're ending at k equals to 4. Right. So here we're looking for t at 1, t at 2, t at 3, t at 4. And then let's see what does that give us. So remember here there's a 2, ladies and gents. So there's no way to substitute k, you see? Because there's no k here. It means this pattern is a constant pattern. It's 2, 2, 2, 2, 2. So it means term 1 will be 2, term 2 will be 2, term 3 will be 2, term 4 will be 2. Therefore, it's going to be 2 plus 2 plus 2 plus 2, which is 8. You see? And then the other thing is this, guys. The simplest way you could have done this is this. If you have a constant here, by a constant, I mean you don't have any letter. You just have a number. You can always do this. You can say, okay, this sum is going to be 2 multiplied by the number of terms. How many terms do we have? We have 1, 2, 3, 4. So times 4, which still give you 8. All right, does that. And then let's erase everything and do the second one. Okay. So the second one, your I is -1. So you can see that, okay, I'm starting at -1, then I'm going to go to 0, then I'm going to go to 1, then I'm going to go to 2, then I'm going to go to 3, right? Then you have I here, you have I there. So you're going to look for t at -1, t at 0, t at 1, t at 2, t at 3. Then you have this. T at -1 will give you, because you're substituting there, will give you -1. T at 0 gives you 0. T at 1 gives you 1. T at 2, I'm sure you see, it gives you 2. T at 3 gives you 3. So you have -1 plus 0 plus 1 plus 2 plus 3. And then you can see that your answer for this sum will be 5. So the answer here is 5. Okay. Let's do this one. So here your n is 2. Please, ladies and gents, pause the video and try it on your own to see if you understood what we have been doing so far, right? So this one, we are going to have, let's see, you are going to have n equals to 2, 3, 4, and 5. So we're looking for t at 2, t at 3, t at 4, t at 5. Let's see what does that yield for us. So you have 3 in bracket 2 minus 2. You're substituting into your Tn formula, remember? Then you're going to have 3, 3 minus 2. And I have 3, 3 minus 2 minus 2. Here you input 4. Here you input 5. Then this, let's see what does this guy's yield. So it's 6 minus 2, which is 4. It's 9 minus 2, which is 7. I can see we're going up in 3, so this will be 10, which is true because 12 minus 2 is 10. 15 minus 2 will be 13. Then you are going to say, therefore, 4 plus 7 plus 10 plus 13, which is 11 plus 23, which is 34. So that's your final answer for this one. Okay. Please keep on pausing and trying on your own and resume the video to see if we are on the same pace. Okay, let's come here now. So here, ladies and gents, I have this basically. I have k equals to 1, and then I have 6. I have 0 to the power k. Do you agree that this can be written as this basically? K equals to 1, and then 6. 0 to the power k will be 0. Do you see it? Because 0 to the power anything, the answer will be 0. All right. 0 to the power any number, the answer is 0. Then remember the technique that I gave you. I said if you have a constant, the 0 is a constant. You have 0, and then you're going to multiply by the number of terms, which I can see is 6. So the answer is 0. Perfect. And then here, your n is basically -3, -2, -1, and 0. So you have 4 terms. And then you can see it's a constant. So it's more or less the same as that. So you're going to say this is equals to 8 times the number of terms. So we have 4 terms there. That gives you a 12. We can prove it by saying, no, that doesn't give us 12. It gives us how much? It gives us 32. Right. So it's the same as this one, basically. You see, the constant, you must know how to do it. You just do the constant multiplied by the number of terms which are there. Let's do this one now, ladies and gentlemen. Here I can see that I'm going to substitute k equals to 1. As you advance, you don't need to list them like this. You must just see. You're going to substitute k equals to 1, you get a. You're going to substitute a equals to 2, you get 2a. When you substitute k equals to 3, you get 3a. Then k equals to 4, you get 4a. Then the last one is k equals to 5, you get 5a. And this gives you how much? It's 3, 6, then 10, 15. So you get 15a there, ladies and gents. Okay. Perfect. Now, this part looks interesting. Let's see how we're going to approach that. Let me just erase here and create space. Okay. On this one, right? They didn't tell, they say calculate the value of what? Of a. We need to get the value of a, right? Okay, let me write my sum here. So the sum of nth terms from k equals to 1 to k equals to 3 of a dot 2 to the power k minus 1 equals to 28. So here they gave me what the answer will be, okay? Remember, please pause and try and resume to see if you got it. So K1, K2, K3 is the last one. So which means I'm looking at T at 1, T at 2, and T at 3. Let's see. So I'm going to put 1 where the K is there. So the first one is going to be A dot 2, then you have 1 minus 1. Then when I have A dot 2, then 2 minus 1. Then you have A dot 2, then 3 minus 1. And then that gives us, let's see. This part we don't need. This is 2 to the power 0, which means you are just left with a, because 2 to the power 0 is 1. Here you're going to have 2 to the power 1 times a, which is just 2a. Here you're going to have 2 squared, which is 4. And then 4 times a gives you 4a. Then you have this now. Therefore, a plus 2a plus 4a, we know what the answer will be. The answer will be 28. Therefore, you have 7a equals to 28. Therefore, you can all see that a will be 4, because 7 times 4 is 28. So divide both sides by 4. Do we get it, ladies and gentlemen? Okay. And the last one is exactly the same as this one. So I'm going to leave that for you, ladies and gentlemen, to attempt and give me the solution on the comment section. I'll approve if it's correct. Thank you very much for being with me and watching these videos. If you find them really helpful, please don't forget to click the subscribe button and to share with family and friends. Thank you so much, family, for being with me in this journey. A luta continua. Tango!